بسم الله الرحمن الرحيم. فإن تولوا فقل حسبي الله لا إله إلا هو عليه توكلت وهو رب العرش العظيم. Today inshallah we are going to talk about the part 2 learning outcome 7. It's talking about what? We talked before about the common ion effect in the last record, common ion effect, and now we are going to talk about the pH curves, the Bronsted and Lowry acid base. For the acid HCl plus water giving to us H3O positive plus Cl negative. In this time we'll find the acid is donor for proton. It's called the acid, and the water is called the base since it's the acceptor for proton. It's called the base. What's formed from the acid after losing the proton or donate the proton is called the conjugate base, while the hydronium it will be conjugate acid. And for base, we're talking about before it in the I think in learning outcome 3 for the acid and base.
Can learning outcome 3 also?
Yes. And it's found in learning outcome 7 else. Ammonia react with the water, giving to us OH negative. In this case, we'll find the water work as the acid, as it's the donor for a lone pair of electrons, or donor for the proton, and the ammonia is called the base. What's formed from the base? It's called conjugate acid, and from the acid it's called the conjugate base. Okay. So if we look this thing, it's called the buffer. It is called for this part only for the Bronsted Lowry acid and base. If we move toward the buffer, what's meant buffer solution? It's the weak acid or weak base resist change in the pH value, like the blood contain the buffer solutions, keeping the value of the pH of the blood is a constant, resist the change. Maybe weak acid, maybe weak base to resist the change in the value of the pH. Right. Let's take an example about the buffer. Let's consider that the buffer as a weak acid like HA.
Okay.
By distillation, it's giving to us H3O positive plus A negative. It is the weak acid, and it is the conjugate base of the weak acid, so it will be stronger type. For the value of the Ka, if I want to calculate the value of the Ka8 will be the concentration of the hydronium. This is plus water. يعني HA weak acid plus H2 liquid. Okay, it will be the concentration of the hydronium multiply the concentration of A divided HA. If we need to bring the concentration of the hydronium only, so the hydronium equal H positive or H3O positive equal Ka times Ha divided A negative. If you want to calculate,
ممكن نشيل H3 ونحط H بوزيتيف صح؟
yes, if you want to calculate the pH value,
نيجاتيف لوج concentration بتاع
negative log the hydronium ion concentration. If we calculate the pH in both sides, so we'll find the pH for the hydronium, it will be negative log the hydronium ion concentration. So negative log hydronium ion concentration or H positive equal negative log Ka Ha divided A negative. So it will be negative log or the B Ka or negative log Ka times negative log Ha over A negative. In this case, negative log it's mean the pH equal pKa dot or subtract negative times negative log Ha over A negative. This is called the Henderson equation. Time is negative log Ha over A negative. It's called the Henderson equation type. Let's take an example for the buffer. If you have 0.5 molar from HC2H3O weak acid, and the value of the Ka equal 1.8 times 10 power negative 5, and we add NaC2H3O2 0.5 molar. Find the value of pH. Firstly, we'll start by the acid, then going to the buffer. HC2H3O2 dissociated in the presence of the water plus water.
HC2H2
C2H3O2 negative plus H positive.
ليه ما قلناش H تاني؟ يعني ليه ما قلناش H تاني؟
Because it's entered in the structure of the compound. Like when we said that CH3,
مش برانش يعني؟
no, COH, the carboxylic group, it is the hydrogen of the carboxylic group, it's responsible for the acidity. So it must be liberated as the hydronium, okay? By ice, started the initial concentration of H3O 0.5, and not considered, and according to adding the buffer, we'll find it's have initial concentration, since it will be dissociated C2H3O2 negative and Na positive, so it have an initial concentration 0.5, but the hydronium ion concentration equal 0. Yes, 0.5 in the step of change, subtract x plus x plus x, so it will be 0.5 subtract x, 0.5 plus x plus x. Value of the x is very small, so it can be neglected. So 0.5 subtract x, 0.5 plus x, it will be 0.5, 0.5. 12 root to 0.5. since the value of the x is very small, 0.5 and plus x. K equal the concentration of C2H3O times H3O C2H3O2. It will equal 0.5 plus x times x. It will be 0.5. Since 0.5 plus x, it will be 0.5 times x over 0.5. So in this time we will find the x equal Ka equal the hydronium ion concentration. So the pH in this case negative log 1.8 times 10 power negative 5. It will be, I think, 4.7. It is the initial value for the pH. I can consider in this case the pH initial, pH initial. Now we are going to make the same step with NaC2H3O2. Okay? Type. I'm giving you the 5 minutes to calculate by this way for the sodium salt. Okay? Start. Okay. We are going to NaC2H3O2 plus water. So firstly, for the sodium salt, the initial concentration it will be 0.5 subtract x. Initial concentration for the S state it will be 0.5 plus x. For the sodium it will be 0. Okay, in this case we will find for the NaOH, I mean for the salt OH or the H positive. For H positive in this case. NaOH. Since the Na attached, listen. Na attached with the OH and the left H in the positive. Okay, we find this species NaOH. Okay, we only talking about the hydronium. Tani. Sodium react water dissociated in H and OH. Na attached with the OH, but in this case we're talking about the buffer, not on the effect of the OH in the solution. We are going to talk about the effect of the acetate and and the hydronium, and only the study the case of the H positive. Okay. It is the initial, the changeable and equilibrium. In the case of the changeable, it will be 0.5 subtract x factor x. Subtract x and this 0.5 plus x and this it will be plus x. In equilibrium, since we have the buffer in this case, so it will be 0.5 subtract 2x, 0.5 plus 2x, and this it will be positive x. And in this case, startly, we will find that concentration of H was positive x. So plus x, it will be x plus x, it will be 2x. We start by 0.5 subtract x because we consider the final concentration in this stage, it will be the initial concentration for the second stage. Else 2x is very small, so we can find that 0.5 subtract x, it will be 0.5, and this else 0.5, and this positive 2x. Find the value of the K. In this time, we will find the value of the K equal the concentration of the C2 H3O negative time is the concentration of the hydronium or H positive divided the concentration of NaC2 H3O2. It will be 0.5 multiply 2x over 0.5 with the 0.5 يبقى K equal 2x. 2x equal 1.8 times 10 power negative 5. So the value of the x calculated from the first step BH1 or BH initial was 4.7. Okay? X equal
1.8 times 10 power negative 5.
yes, 1.8 times 10 power negative 5 over 2
9 times 10 power negative 6.
9 times 10 power negative 6. So the BH negative log hydronium ion concentration or the value of the X, so it will be negative log 9 times 10 power negative 6 5.04. It's called the BH final. So the BH equal BH value for the buffer. BH final subtract BH initial equal
4.34.
yes 5.04 subtract 4.7 equal 34. So we'll find the value of the change in the BH is very small or the little amount. That is the effect of the buffer.